Gonna do it anyway. All right. First off, Allison has wanted a shout out on these videos for months, and I keep forgetting. So shout out to Allison for never being here and still getting an A on the test, which really does piss me off every time. Questions?
Does it really make you that mad?
Wouldn't it make you mad?
Well, so she's still getting a good grade in your class.
But she doesn't do anything. I would rather the kids that work hard get A's. Okay, here we go. Delta G naught is equal to negative R, which is 8.314, times T. The T here is 298, times the ln of K. All right, K can be solved for, say that again. All right, this negative technically would be outside here. It doesn't matter, FYI, but whatever. All right, here we go. K is the expression which we have done for weeks. It's NH3 squared. Are you okay with that? So it is 0.5 squared. The squared comes because of that. It's products over reactants. So then it's N2 to the first, so 1 of N2, and H2 to the third, so that's 3 cubed. And that will give you some sort of number. 009? Okay. And so then you take that value and you put it in here. Oh no. 11,600? Don't panic. These can be really large numbers. First, and also, by the way, if I remember, this is in joules, so it really is just 11.6 kilojoules. So it's not like, it's not that big of a number. Don't panic when you get that. Okay, let me, yeah, I've actually noticed that. Okay, so now use these values. We're pretending these are the values you would find in Appendix C. Calculate delta H, calculate delta S, and then once you have both of those, then you solve for delta G. All right, so you need all of them. Okay, have fun, my friends. Everyone's going to be scared because the calculator always lies, right? Negative 248. All right. 248.5. Okay. If you didn't know how to do that, that was the sum of reactants. Products, I mean, right? Minus sum of reactants. Good? Okay, fine, peoples. All right. I swear I heard a 0.5. All right, that was the sum of the product of reactants for the H's. S, you do the same idea. What did that end to be? 1.025. Just for fun that time. All right. Now, I made these both the same unit just to be nice because I can be when I feel like it. Now, delta G is equal, if you remember, the way we calculate it is delta H, right? Negative 248 minus temperature, which is 400. All right, and that is multiplied by delta S, which was 1.02. No? Oh. I'm going to make that an X, so it's not confused for another decimal. What did I do wrong? Oh, okay, I guess we are on A. No, it's fine. If you did it either way, we're gonna find these values at 298 because that's what they are in the table. But we will will then use those values to estimate delta G at 400K. And that's very common, and that's how you do it. So this should technically be at 400. If you did 298, that's fine. You've learned now, don't do that. But this does happen quite a bit. All right. So now, what does this end up being? Negative 657, you multiply instead of subtracting. Negative 6. Just for fun. All right. I know, I'm bugging people, but I get paid to do it, so it's fine. Okay, now, on these questions, they'll always ask at least one qualitative question. Is this spontaneous at 400 degrees? Yes. Why? Delta G is a negative value. Okay with that? If delta G is negative, it's spontaneous. All right? They will often ask another question here. How does delta G change as temperature increases? Will you have that discussion with your partner real quick? How does it change as temperature increases? Yeah, as the temperature goes up, what is happening to delta? Okay, so how do we answer that? Delta G does what? All right, more negative. Or you could also say it becomes more spontaneous. We okay with that question? All right. Let's see, is there another sliver I can add here? Yeah, what is the value of K at 400? Oh, there's actually not a degree sign on Kelvin. Sometimes I do that. Okay, what is the value of K at 400 Kelvin? What's that? Yep. So try that one real fast. Okay, so if you don't have this in your notes, that's the one we're going to use. All right. Did it work? Okay. So K will be equal to E raised to negative. So can I just write it positive? Is that okay? And we said it was 656. Is that what we have? Okay. Over RT 8.3145. Because I can't. And 400, that's a 400. We end up with 1.21, 1.22. Okay, I got a question. Is this product or reactant favored? Someone said, I heard it. It's product. Now, it's not by much, right? So this goes back to chapter 15. If this value is above 1, it is product favored. If it's a decimal, like when we say less than 1, we don't mean a negative value. We mean if it is like a decimal. Between 1 and 0, we would say it's reactant favored. So really, this being really close to 1 actually means it's almost at equilibrium with all those numbers we made up. Okay, let me see something here. My made up numbers, we didn't even get close, but that's okay. Not that it matter. Like, if any chemistry teacher ever has any of these memorized, that person has too much time in their lives. Yeah, he probably does. Thank you, birthday yesterday girl. Why? You don't like my Bozeman science sound for the start of their YouTube videos? This is on video, Diane. This is on video. Ear spasms. Don't muscles. Isaac or Allison watches this, or Island, or Caitlin, they watch them. Tomorrow, I'm going to give you a 3-question quiz. And we're going to call it the test. Yep. One of them is going to be just like what we just did there.
Make it worth 100 points.
I am making it worth 100 points. Yeah. You have a problem with that? Faux shizzle. Where are you from, girl?
The 2005?
All right. I liked it, actually. I'm going to call her Snoop Diane. All right. 3-question quiz. One of them will be just like this problem, where I will give you the values, but you have to calculate delta H. You have to calculate delta S, and you have to use that to solve for delta G's. Yeah, I'll give you the equations. Okay, then I will definitely ask you if it's spontaneous and why, because the AP test definitely will. That's a good looking check mark. All right, then I will definitely ask you, how does it change as temperature increases? Okay, I don't know on this same problem if I'll have this on it, but I do know on one of my other ones, I definitely have this as well. Okay, it could be either direction. Okay, I might make you solve for K using chapter 15, like our concentrations, and go the other way like we did earlier. Or I might have you do it this way. So that's one of them. The other 2 questions, us working through this problem 2 days ago, was recorded and posted. This was Monday. Okay? This time it gives you the value of delta H. It gives you the value of delta S, and you just go from there. You okay with that? Like it's the exact same stuff. This one's just a little bit easier. Okay? It talks about, hey, why would a producer do this if it was at cold temperatures? That was because it produces more yield. It might be E or whatever. Why would they actually do it at a higher temperature? And that was because it's related to the rate. Does that sound familiar? Okay, that's one of them. The other one, it's like this. All right. So this, I guess, is like the one we already did. But anyway, it's the same concepts over and over. You okay with that? Because really, there is only 1 or 2 concepts in chapter 19. So 3 questions. The variety will be lacking. There's no multiple choice. I will assume you have read chapter 19, and you would get an A on the multiple choice if I gave it to you. Are you okay if I assume that? Okay. Okay, never mind. Whoever wants a multiple choice. Anyone else want multiple choice? Oh, I thought I heard no. Okay, do you have any questions? Okay, then I am done.